As network engineers, I'm really excited about this next video or this current video about troubleshooting our code using the debugger. So the debugger is the built-in tool into your developer environment that allows you to know what's going on or what's going wrong with your program. You can use it for both, for learning and for fixing problems or diagnosing them. And here's where you can feel ahead as a network engineer who codes compared to software engineers, and that is by mastering your debugger. There is this big joke in software engineering world about how everybody troubleshoots their code by using print statements, which we've learned a couple of videos back, right? They just, whenever they want to know what's going on, they sprinkle in print statements here, there to figure out, hey, like what information is this variable actually holding? Or what is the output of this function? What is this function producing? And here's the thing. In our course, we are still early on in our journey to learn to code, right? So you might think to yourself, yeah, that sounds pretty easy. Just throw in some print statements. I like it. I know what that is. However, it's not very professional. So just in terms of finding a job or proving yourself on the job, you're going to come off a lot more professionally, like you know what you're doing if you use your debugger. But also, and more importantly, is that one day you are going to code things that get more complex, or that involve more lines of code, or that involve more files and things that depend on each other. And so at that point, you're really going to want to use a debugger to save yourself time rather than constantly spending the time inserting and removing print statements that honestly might not even give you the information you're looking for. Now, this video, just like the others, is all about exposure therapy, right? So I'm going to expose you to the debugger and ways that you can begin using it. However, there's going to be parts of it that don't really make as much sense to you yet because we have not gotten that advanced. And so I'm going to need you guys to build a habit, right? Build a habit of trying to use the debugger when you run into an error with your code. Or if you just like have written some code in the past that you don't exactly remember what it's doing and you just want to see step by step what it's doing, or maybe you've copied and pasted some code from the internet or from ChatGPT or from a colleague, and again, want to understand what it's doing. I know we're in the age of AI right now, but this would be a great way to start getting comfortability with your debugger. So as always, let's get to it. So like we mentioned before, we can use our debugger tool to understand what's going on at a detailed level in our code where we step line by line and see what's actually happening here, or we can later on use it to diagnose issues and troubleshoot errors in our code. Now, from a teaching perspective, and because you're so new to this and being exposed to this, it's going to be a lot easier for us to just focus on, how do we walk through our code line by line and understand it? Organically, naturally, later on, you are going to run into issues in your code and you're going to remember what you learned here and be able to use those same skills to troubleshoot those issues. And this is our file from last time. If it does not look familiar or you did not watch the last video, please go back and watch that. Again, this is a course. Please watch these videos in order and try to practice to get the most out of this and in acquiring this skill set. Right, so we had one function where we're adding days uptime between two switches, and I commented out this other one about firewall active status. We're gonna go down to this other function we wrote where we check whether or not the primary link is up, and if it's not, we're going to switch ISPs. And I'm going to actually start here for walking through line by line and explaining what this code is doing. And even when we get into using AI with our code, again, these are the foundational skills you need. So even though you might ask AI about what code is doing or how to troubleshoot it, you want the foundational skill to be able to verify what AI is telling you. You want the skill to be able to do things with your code if AI is ever down, etc. Anyway, let's get into it. We're checking if the primary link is up and switching if it's not, switching ISPs if it's not. We've got a variable up here on line 35 that says that holds the link up state. We've made it a Boolean or a bool, whatever it is in Python. We've set it to true right now. In our program, it just stays true. It just stays whatever we've coded it as. And we're passing that link up variable, that value, into our function called reroute traffic. And we have an if-else statement in here. But if the value of what is passed in to this function is false, right? Which in this case, link up is what's being passed in. Then we're going to print, okay, we're rewriting the traffic. We're not actually doing it, right? We created the simplified version for learning purposes. And how do we know that link is actually referring to link up? Well, again, when you pass in a variable in your instructions, when you create instructions for a function, you then have to call it to bring it to life to actually run that function, right? We do that down here at the bottom on line 45. We call the name of the function, and when you call the function, you have to pass in whatever it says that you have to pass in. I'm saying, hey, some value for link is required in order order to run this function. And so when I called the function down here, I had to put something here or else the function was not going to be called. There would be an error. And so I've specified, hey, link in this case is the value of link up, which is on line 35. So let's use our debugger to see what's going on. So there's a couple of different ways that you can run the debugger. And this is going to be probably pretty similar no matter what your developer environment is. I don't think I know of any developer environment that doesn't have a built-in debugging tool to troubleshoot your code. So we've got two ways over here. On the left-hand side on our navigation menu, you see a play button with a little bug. I think that's a pretty common way to represent it. You can see that you can run the debugger just straight up, or you can include some automation here. The other way that you would find that is up here at the top right. Instead of just hitting play and running the file, you can hit this little arrow right next to the play button, and here you can get more specific and say, hey, I want to run the Python debugger and debug the Python file. And now we see two things that are different, right? First of all, we have our new run and debug console open over here on the left, and we're seeing variables, and we're seeing a category that says watch, and we're seeing a category that says call stack. And then you've got some other options here at the bottom. So here's the thing. A lot of this is not going to make sense to you right now, and you need to not get hung up about it because it's things that you haven't been taught. It's things that you haven't run into. There's a lot of times when teaching coding concepts of this like chicken and the egg problem, or like when should I introduce something to not do it too early, but before they're going to need it. This is kind of the situation with the debugger where I definitely think that you need to understand how to troubleshoot your code before using AI. But in this course, you're not really getting it that advanced before you start using AI, and so there's just there's a big gap there is what I'm trying to say. I think what's most important here is to just be aware of these sections. Don't worry about whether a variable is global or local right now. You'll learn that very soon. It's not a super complicated concept, but again, I can't overwhelm you with crap. Watch is if you wanted to create a specific expression to be watched, and a call stack, again, this is a little bit abstract right now, but it is essentially just the order of calls being made in your program. And you might be thinking to yourself, like, why would that exist? Like, obviously, I'm just calling this one function right here, my reroute traffic function. Like, why is this a whole separate section? Well, again, your code is going to get more complex, or depending on the type of coding you end up doing. As an example, you might use something that's built into the Python language itself, and that call stack is going to look very different. You might not recognize everything in that call stack because you're not the one who wrote the code, but your call stack can later involve other people's code. You might have a function that calls another function. There's just a lot that could be going on. I just want you to be aware of what that section is. The last thing that you should know is that when you hover around here, now, next to the line of code, you'll see this like red dot that's following my hand here. And if you hover, it says click to add a breakpoint. Well, the purpose of the breakpoint is to stop your code at specific points. So when you run the debugger, it is going to stop wherever you've set a breakpoint, and you'll have the option to just kind of step past that, like, hey, I don't need to see anything else with this line of code. I'm just going to kind of move on. Or you're going to have the option to step into it to further examine what's going on in that line of code. So I've already got a breakpoint here at line 39. I've set one here, if link equals false. And you'll see that when I ran the debugger, right, it says link equals true. So it says it right here highlighted next to the line of code. We can also see it over here on the left in our local variables, right? And again, don't get caught up in what local and global is right now, but it says link equals true. So if I was trying to understand what was happening with the code and like, man, like, why am I not seeing this print statement? The traffic is now rerouted to ISP2. I could run the debugger and see, oh, well, that's because it's showing that link is actually true when it hits this if-else statement, which means that it's not going to print this. So, and if you see it here, also here at the top, we have this shorthand where we can continue debugging, right? Going to the next breakpoint. We can step over this code when we can step into it. So just for giggles, let's step into this code and see what happens. So when we step into it, in this case, it's showing us the consequence of this line of code, right? You can see that now line 42 is highlighted, right? And it already told us at our breakpoint, hey, the value of link equals true. And then when I step into it, it's saying, hey, that is causing it to go to this else statement and to just ultimately pass and do nothing in this function. If we're done looking at this, right? Or we can continue to step into, right? And follow it line by line, what's happening with this line of logic. If I hit it again, right? Then it returns link equals true. It's telling us what the value is. We can also step out. So let's try setting multiple breakpoints now and just like see what happens, see what this looks like. So I'm gonna put another breakpoint on line 38. Let's put a breakpoint at else. We're just gonna kind of like willy-nilly add us some breakpoints because maybe we just don't know what we're doing yet and we're getting used to the debugger, right? So I've set these points up. I think this, yeah, let's restart the debugging. So to start at the top at our first breakpoint. So again, there's a whole file of code here, and it skips all of it, and it hits straight to this first breakpoint. Link up equals true. We can see our variables so far in the program, which includes, you know, like all that stuff that we don't care about right now, like our ACL list, our switches, blah, 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 right? All of that stuff is still stored over there in the locals variable tab, so you can see it, but we're on line 35 right now. And you know, you might have thought to yourself like, hey, why don't I see link up over here in the variables? And that's because we haven't yet stepped over or into this line. So we're waiting here. We have not yet executed it, but when we do, it should show up over here in the variables section. So let's go ahead and step into this, and it says link up evaluates to true. Now let's look at our variables section, and there we go. We see link up equals true. So it shows up once we've actually stepped through it, over it, whatever. We've already done this one. Let's see what happens if we step over. If we step over, we just skip to the next one. Also, thanks for your patience with this explanation, because nobody ever really taught me ever how to use a debugger. The only explanation I got of using a debugger was actually from my dad, like informally, who works as an engineer. But I've like never really seen much information on debuggers. And it's also not something I've had to explain before. So thanks for your patience. You know, let's run it again. Let's run it again. I just want to show you an example of each. I want to show you an example of the step over. All right, so we've got link up equals true. We already know that that variable is not in the variables list. So let's do step over. You'll notice that link up still appears here in our variables now, but we just move straight into def reroute traffic. Let's step over. And again, here's the difference between step over and step into. When we step into this function, it tells us what happens next, right? It follows the entire line of logic. But when I say step over, I say, hey, skip over to the next thing happening in the code. And it takes us to here where we're calling the function. I removed all those breakpoints. I re-put that breakpoint there at line 39 if link equals false. Let's run our debugger file again, and let's try to demonstrate the difference between step over and step into. That's the one thing that I feel like I've not really effectively demonstrated yet. So in this case, it's so simple that step into and step over don't really have any difference. And I am going to use AI because, again, this is complex to explain and I've not yet tried to explain it to anyone before. Here's an AI overview from Gemini as well to help aid your understanding. The key here between step over and step into is if the line that you have a breakpoint on contains a function call, step over will execute the entire function without pausing inside of it. However, with step into, if the current line contains a function call, it will enter that function and pause execution on the first executable line within the called function. Again, this is abstract. You really don't have that problem and understand when to use that right now, but I need to at least expose you to the fact that this exists before we use AI, okay? Just please trust me, guys. And thanks for allowing this new and abstract information to enter your brain, because I know that you have like not really any points of reference here. So that was our super quick, as simple as could be made with the debugger introduction to the debugger, right? You know it exists now. You know we've got options to step over and into our code. You understand what that debugger window looks like the kinds of information it might show you. And now I've planted the seed in your brain that, hey, as I become more skilled, I should be practicing navigating my code with the debugger so that I can gain comfortability with it. And when I start coding more difficult things, you know, I start working with other people's code. I start having more dependencies depending on other things, other people's code within my code. The debugger's not going to be this foreign thing that I've got to learn how to do, you know, X years into my career. But you might be asking yourself again, hey, using these print statements to know what's going on seems like way easier. Why do I not just do that? Again, it's all dependent. Adding a print statement is sometimes the easiest, just quickest way to know what's going on. Like if I wanted to know the value of link here, right? I could add a print statement, add print link. I could run this file and I'm going to go back to this right side because you see the little bugs on it, so it's running in debug mode. I want to run it regularly now. Run Python file. Okay, and it didn't run that code at all. It did not print anything from this function in the terminal. So why did it not print anything? We got our add days uptime. Oh my gosh, I just did this in another video. It's not showing us anything from this function because it's only going to print this if the link is false and is currently true. Oh my gosh, at least this is good practice for you guys. So let's turn this to false so that something will actually print out. Let's hit run again. Here we go. Now we see traffic is now rerouted to ISP2 and we see false here. So it's printing both of these print statements. Now, if that's all you need to know is like, hey, what is link evaluating to, true or false, then adding a print statement here is a lot easier and faster probably. It's also really easy to just like remove one line of code. This would be my generic recommendation for when you need to stop with the print statements and move on to the debugger or possibly later on using AI. And that is when you find yourself adding multiple print statements. So I would say at a maximum, you should not be using, I don't think you should be using more than 2 print statements to know what's going on, but let's say 3 print statements to be generous. If you've used 3 print statements throughout your code to understand what's happening line by line, and you still don't know what's going on, it's time to use the debugger because again, it's starting to become inefficient. You're not getting the full picture and you got to remember to remove all those later to avoid security issues or just, I don't know, people being annoyed that you're adding random print statements. The other thing to keep in mind, and I didn't really go over this yet when I talked about the print function when I first introduced it to you a few videos back, and that is that you can't just print anything. If I type print here and then I put the parentheses, I can get more information about it, right? It's kind of like built-in documentation on the print function within our developer environment, right? We don't got to Google it or ChatGPT it, whatever. And it tells us what kinds of things can go within here. So first of all, it says prints the values to a stream or to a sys.standard out by default. So that tells us what the function does. We don't really care about the rest of this right now, but up here at the top, it typically tells us what types of data we can use. So it says values, object, or sep string. str is string. We've learned about strings. And sep is a string inserted between values, default a space. Again, this sounds a little bit abstract, but so we're talking about objects and we're talking about strings, but again, when you're not used to navigating this, and to be honest, even as somebody who codes or as a developer, it can sometimes not be super clear what these explanations are saying. So let's just try printing things and run the experiment. So let's try printing a string, which is like, we love to code, ha 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 ha. And then let's try printing a variable. Let's try printing the value of link. Oh, actually, we can't do that. Let's try printing the value of link up. This is a variable that holds a true false statement, a bool or boolean. Let's try printing a number. Let's try printing 65. So that's an int. Let's try printing a float. So that's a decimal point number. Let's try also like printing a function. Like, let's see if we can print out a function. All right, so let's run the experiment. Okay, so I just ran the code, and here's what we see. We see our traffic is now rerouted to ISP2. So we see all the other stuff printing from this file that we're not concerned about right now. And then we see our print statement we love to code first. Why do we see this print statement before we see the print statement from our function? That is because Python is running the functions we're calling in order. So technically we define our function here, but we're not calling it here. The first called function in our code are these print statements. The first functions we're bringing to life, having act, execute, are these print statements, and we do those in order, and then we officially call that reroute traffic function. So that's why you see traffic is now rerouted to ISP2, false, from this code at the bottom. So let's see what printed. So we see we love to code, ha ha ha, so that worked. Then we see false, so let's see, that's the value of link up, so it did print link up false. 65, we have 65 printed, so it was able to print an int. It also printed our 64.78. And then it looks like it also printed the output of reroute traffic link up because we see traffic is now rerouted to ISP2, false. I'm actually trying to figure out where the false is coming from because we're not printing false anymore. It might be because I didn't save the code. So I just hit Command S. Let's run it again. No, where is the false coming from? Am I having a brain fart? Let's comment this out. Okay, so it's definitely this function that is printing both traffic is now rerouted to ISP2 and that false line because now it is not showing that. It's only showing the first one for line 50. So why is it printing false? So I guess what's happening here is it's printing the value of reroute traffic and maybe it's also printing the value of link up. Let's try removing just for giggles. Okay, so now when we try to print it, we get this error. Function reroute traffic at blah, 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 blah. So we can't just print reroute traffic. Let's try it with the parentheses. Now we get a trace back, which is basically an error message. Tells us on, in this file, which is the file we're in right now, on line 48, which is this line that we're modifying right now, the function print reroute traffic, there's red arrows, and it tells us what the error is. Type error, reroute traffic is missing one required positional argument, link. We already know this, right? We know we're supposed to have something there. Let's try link equals true. Okay, so it looks like when we print the function with what we're passing in, it looks like it's printing both things. So now we change the value of link to true here, and now we're only seeing true, right? Because the traffic doesn't get rerouted. Okay, so I learned something too. Very interesting. Let's change it back to link up. And now I've got traffic is now rerouted to ISP2 and false is the value of link up. All right, we learned something together. Okay, so this was a much more kind of abstract session, I think, compared to usual. Please do not get discouraged. We have to add baby steps of knowledge. Right? So you're going to need the debugger later on, and so you need to know at least what it is, have an idea of what it's used for. It does not matter if you exactly feel confident in what I did here today. Whatever. The point is just to practice, right? And to develop your own intuition around using the debugger and troubleshooting using it. And you also have a better idea of using those print statements, how to navigate that, and when you should and shouldn't use them. Stay tuned for the next video in the course. We're getting so close to being done with our foundational concepts here before moving into the AI section. I'm so stoked for that. And as always, let me know if you have any questions, comments, concerns, whatever, down in the comments. Take care, guys.